Okay, hi guys. So we are told to use the bisection method to find the root of this particular equation. So the first thing you want to do is that you want to find an interval, a starting interval, to know where the root lies in between. So in order to find that, we assign x to random values. We usually start with 1. What we're looking for is when the sign will change. Let me just explain it. So f of 1 is what equals to 1 squared minus 2, which is minus 1. You can see minus 1 is less than 0. Now let's try x equals to 2. At that, we're going to have f of 2. So that will be 2 squared. That's 4 minus 2. That is 2. 2 is greater than 0. So at this point, there's a sign change. Therefore, the root lies in between 1 and 2. X equals to 1 and x equals to 2. Because there's a sign change in between them. Now, we then start with our first midpoint. So for x naught, I like to start with x naught. You can start with x if you want. So it's going to be 1 plus 2 over 2 equals to 1.5. We now put it back into the equation. 1.5 equals to what? 1.5 square minus 2, which is 0.25. Now 0.25 is greater than 0. We go to the last root that had less than 0. In this case, it was 1. So now we know the root lies in between 1 and 1.5. So now we go to our next midpoint. X1 is equals to 1 plus 1.5, right, over 2. So that's going to be equals to 1.25. Now 1.25 is greater than 0. So now we put it back into the equation. That's going to be equals to 1.25 square minus 2. That's equals to minus 0.4375. Now this is less than 0. We go back to the last root that had greater than 0. In this case, it was just this. So now we know our root lies in between 1.5, that was at this point, and 1.25. Now for the next in x2, so that will be 1.5 plus 1.25. Usually I like to write the lesser number first. So 1.25 plus 1.5 all over 2 equals to 1.375. Put it into the equation. That's x of 1.375. That will be equals to 1.375 square minus 2. That's equals to minus 0.109375. Try not to reduce the amount of numbers you get. So this is less than 0. We look for the last number that was greater than 0. In this case, 1.25 was less than 0, but 1.5 was greater than 0. So now we know that the root will lie in between 1.375 and 1.5. So the third midpoint x3 is going to be equals to what? 1.375 plus 1.5 over 2. That's equals to 1.4375. Now if you take this into the equation, 1.4375, that's 1.4375 square minus 2, right? So it's going to give you 0.066400625, which is greater than 0. Now you can see the equation is starting to give us a lot of zeros, so we know we're close to the answer. So if this is greater than 0, we look for what was less than 0, right? 1.375 produced a value that was less than 0. So now we know the root lies in between 1.375 and 1.4375. So again, also our fifth midpoint, that will be 1.375 plus 1.4375 all over what? 2 equals to 1.40625. Put this into the equation. You're going to get 1.4625 square minus 2. That's going to give you minus 0.022460937, which is what? Less than 0. So we look for the last value that had something greater than 0. That's what's here, 1.4735. So now we know it lies between 1.40625 and 1.4375. We go next again. X5 is equals to what? 1.40625 plus 1.4375 all over 2. So that be equals to 1.421875. Now if you take this into the function, it's going to be this square minus 2, which is going to give you 0.0217285155625, which is greater than 0. We look for the last value that has something less than 0 at this point. So now we know the root lies in between this and this. So now our seventh midpoint is equals to 1.42 plus 1.40625 all over 2, which is going to be equals to 1.41400625. If you put this into the equation, It's going to be this square minus 2, which is going to give you minus 0.0004272460937, which is less than 0. We look for what was greater than 0 last, which is this. Now, as you can see, this is approximately 0, it's basically 0. So we can stop at this point and say that the root of our equation x squared minus 2 because 0 is 1.414065. And yes, actually, if you do check it, the root of this is actually root 2, which is 1.4142. So it's off by a little account, but you get the point. So thank you for listening.